So in this case, we are going to consider as a continuation on our measurement, working with question papers. There's another exam question that we have on question number 7. Given 7.1, we need to understand the information, how it is given. They're saying the roof of a canvas tent is in the shape of a right pyramid. That is the roof, having a perpendicular height of 0.8 meters. The perpendicular height, this is the indication that we are given, which is the perpendicular height, this one, 0.8 meters on a square base, meaning to say this here lies on a square, as we are to consider from that point, going to the point at B, like that. It is on a square. The base that is on the ground is a square. Considering whatever that you're going to have on this other side, this is a square. That is the presentation that you're given. So we have a square. The length of one side of the base is 3 meters, as we are given. So FE, meaning to say also this is 3 meters. This is 3 meters. Remember, we're given this as a square. This is 3 meters, everything 3 meters. It's a square base. All right, this is what we had. It's a square, remember? Then the question is on 7.11, calculate the length of AH from A to H. All right, with this indication, we can see that there is a triangle that is formulated if you consider properly here. This is your AH here, this line. But remember I told that this is the perpendicular height, 0.8. This is the perpendicular height as it is going to meet with the base like this. It is going to meet at what? At 90 degrees. So if we check properly, we are going to see that there is a triangle that is being formulated there from A to this, which is this vertical line meeting with the horizontal line, which is going to H. This is the point A, and this is the point H. There's this vertical horizontal concept. They meet at what? 90 degrees. So the vertical line, which is the perpendicular height, is this distance. Remember they said, they gave us that perpendicular height. The perpendicular height of what? 0.8. On the square base, this one on top, 0.8. So this is the one that we have here. There's a 0.8 meters here. What about from this point? This is at the center as, this is what happens. These points, they all meet from the corner here to this point. From this corner here at G, this way, they meet here. From this corner at C, they meet here. From this corner at B, they meet here. All they meet at that point where the perpendicular height is here. They meet all these points, they meet here. So that point is referred as the midpoint, where this one is the midpoint of all. It's like the center. So a center point, if you understand that way, a center point, midpoint. So if it is the midpoint, it's simply half of the distance. Whether I'm moving from this to here, it's half of the distance. It's a square. They said it's a square base. So it was going to be half of the distance. If this is 3 meters, half of that 3 meters is the one that you have to consider. So half of 3 meters, it was going to be what? 1.5 meters. It is half of that. So that was going to be 1.5 meters from that understanding of a square base that is on the base there. You have to take it that way. The perpendicular height will be in the middle position. So that was going to give us AH, because this is a right angle triangle that we are formulating from there. And we are given two sides on a right angle triangle. Pythagoras theorem, C squared is equal to A squared plus B squared, or A squared plus B squared is equal to C squared, depending on the way that you understand. C squared being our hypotenuse, AH. So that is AH squared is equal to A and B. These are the shorter sides that you're given. 0.8 squared plus 1.5 squared. So you simplify this together, that was going to give us a value of 2.89. As we combine everything, we're going to get 2.89. This is squared, and you need AH. So how do you remove that square? Introduce the square root. Introduce the square root. That is obtaining the value of AH. So you can even use this like with a bracket like this like a bracket. This is one and the same thing, or you can just leave it like that. Moment to introduce the square root, you are removing the square. So the square root of this one, the square root of 2,89, which is 1,7 on your calculator, that is the length of AH in meters. So that was going to be 1,7 meters, which is like a slant height, this one, slant height to that base. That is what we had there. All right. Then let's consider other part, 7.12. Calculate the surface area of the roof. Of what? The roof, the surface area of the roof. All right, the roof we are talking about, the top part here. This is the roof. So if you consider the top part, you're going to see it is like this, guys. I want you to see properly here what is happening. Remember, you calculated this AH. So on the roof here, you see this part here. This was important for us to notice. If you check this part here that I'm indicating, this triangle as ACB, it's part of the roof, this one, this ACB. Well, let's work with it because that is where we have measurements because we calculated AH. Remember, if you check here, it is taken at what? At 90 degrees, A to H, as it meets the triangle ACB, as it meets this triangle, the line AH that we just calculated. It was just a normal line here on this presentation of the previous triangle that we used. But on this triangle ACB, this one, it is no longer just a normal line. It is the perpendicular height. As we can see, it meets at what? At 90 degrees. So we can think along that. Since we need the total surface area of the roof, the top part, remember it's made from a square base. Remember, it's made from a square base. So if it is made from a square base, this is the idea, guys. As it was going up, there was a triangle that was going up to meet at a certain point. There was a triangle which was taken to meet it, but also another. So there were 4 triangles. But with this indication, you will not see the part that I'm explaining. There's this triangle here, 1. There's this triangle at the outer from A to that corner there to be like this. Another triangle. There'll be a triangle that will be taken from A to that corner to that like this, which is the view that you are seeing there. There will be a triangle that will be taken from A to G to C like this. There will be 4 triangles, including the first one, this one that we had. Because they are from a square base, so you just count number of sides, 1, 2, 3, 4. So there are 4 faces of triangles. Which form what? Which form the roof. So in this case, that was going to give you the surface area of the roof. That's 7.12. So we are saying, as of the roof, it is made up of what? It is made up of 4 triangles. Of 4 equal. There will be equal triangles, so that will be specifically 4 equal triangles. So if it is made up of 4 equal triangles, therefore to calculate its surface area, we'll need, in order for us to have the surface area, I'm just going to write in short, surface area of what? Of the roof. It is going to be 4 times the area of one triangle. And as I said, we can use the triangle ACB, this one like this. We can see there's A, there's C, there's B. Then there's this point which is taken, this line taken from A to H. Remember, we say this meets at what? At 90 degrees. And that is the AH, which you calculated here as what? 1,7 meters. And CB is the side of the square. Remember, this is 3 meters, meaning to say also 3 meters there. From C to B, we also have 3 meters, 3 meters. This is 3 meters. The square base, 3 meters, like that. That is the idea. So if we check this triangle, as it, there are 4 of them of this same nature. There are 4 of them where the base is, and they have the perpendicular height being the same. 4 of them. So it was going to be 4 times area of one triangle. Area of one triangle. Meaning to say it is 4 times. How do you calculate area of one triangle? Half base times the perpendicular height. So that is the idea there. We have the surface area of the roof. We're talking about the roof here on top, the roof. So 4 times half times the base. This is the base, 3. The perpendicular height is the one that you calculated now, A to H. Remember our point H here, A to H. That's your perpendicular. It meets at 90 degrees. There's 90 that is indicated there on your diagram. There's a 90 degrees there. That's the perpendicular height of that triangle, 1,7. So this is it. This is the area of one triangle, this one. But we say there are 4 of them forming the roof. There are 4 of them. So that was going to be 10,2 if you multiply everything, square meters. So this is what? The roof. Only you're considering the roof, the top, made of 4 triangles. All right. 7.13. If the height of the walls, take note, of the tent, the height of the walls now, we are considering these walls of the tent, like the height of the walls, is 2,1 meters. Calculate the total amount of canvas required to make the tent. If the floor is excluded, the floor you're talking about this. Remember, the floor is the one that is made from that square that we are using, the 3 meters, 3 meters, 3 meters of that base that we are given, like in terms of the size, 3 meters, 3 meters. These 3 meters that we're talking about, this one, the length here, this one, the 3 meters here, this one, the length, the 3 meters, this one, the distance here, this one. The square, this one, it's a square base. It's same 3, 3, 3, 3 as it is. So they are saying its length now of the 10, like going up here, going up, it is what? 2,1. So we have 2,1 meters going up. Same side here, 2,1 meters going up. Same size here, going up, 2,1, going up, 2,1. We're not talking about this distance, guys. No. This is the part of the base, the square that we had on the base. On the base, there's a square. Also here on the top here, there's a square here on top, like the base of it on top, it's a square. Same as we have here, it's a square. But as it goes up, it's no longer a square. So we're talking about what? A rectangle, this one. It's a rectangle, this one. So as we can see, where the canvas will be affected, it's on a rectangle. On a rectangle like G, C, F, E, like this. It's a rectangle, this one. This one. Which is the same as this one that is also showing this side. There's a rectangle there. There's also another rectangle which is hidden there. There's also another rectangle there that we see there. The 3 meters and what? The 2,1. There are 4 rectangles because they are saying exclude the floor. This is the floor. This one is our floor, the base here. So exclude this one. On the floor, what do we have? We have a square. This is our floor, this one. It's a square. Which is the what? This one. They are saying exclude this. With the floor excluded, the floor is not included. So what is going to be your surface area of the canvas? So meaning to say, you are going to consider everything that we have on this diagram, but just remove the floor. Already we calculated here the roof. We calculated the part of the roof. So for us to have the total now, we have to include now this part of what? The tent, which is this of these rectangles that we are talking about, 4 of them. Remember, a square, it is giving us like this to say the base, it's a square, which is very true. But as it is going up, there's a rectangle here going up. There's a rectangle from these 2 sides, a rectangle, these 2 sides. So there are 1, 2, 3, 4 rectangles. Just like what we saw on those triangles here. There will be 4 rectangles at the end. So in this case, guys, they simply need you to calculate the total surface area. They wanted you to calculate the total surface area. So that was going to be the 10,2 that we calculated before, plus what is remaining, excluding the roof, excluding this part of the floor. We said we've got 4 rectangles. So we are going to multiply 4 times area of each rectangle, length times base, or you are using length times width. There are 4 rectangles that are to be taken into consideration. Add to the one that you had in the first box. You need the whole of it, the total surface area. This one was the surface area of the roof. So you must add to that one. So that is going to be 4 into the length and the base. Remember, we are given 3 meters going up. As it is going up, G to F or E to C, this D to B going up is 2,1 meters. So that's 3 times what? Length 3 times 2,1 meters, just like that. So that was going to give us the total surface area. We're going to get 10,2, and this one was going to give us 25,2. So if you combine these two, you're going to obtain 35,4 square meters. We are talking about the total surface area. That is what the question was all about. So you have to be careful what you calculated and anything that is needed. But they are saying exclude what? The floor. The floor is not supposed to be involved in your calculation. Remove the floor. Let's consider another question. Okay, this is no longer about what we had. Okay, this is another question on its own. They are saying on this question here, a metal ball has a radius of 8 millimeters. A metal ball. The moment you talk of a metal ball, we are talking of a sphere, not a circle, just a sphere. So we are given its radius, which is 8 millimeters. And the volume they gave you, the formula, 7.21. Calculate the volume of the metal used to make this ball. Give your answer correct to 2 decimal places. Calculate the volume. Already we are given the formula there. So it was just going to use, we're just going to use our formula. 4 over 3 pi r cubed. So that is substitute 4 over 3 times the pi times r there, which is the radius, in millimeters. So that is 8 cubed, meaning to say the volume will be cubic millimeters since we are using what? Millimeters. So make sure that you use your calculator properly. In your simplification, you're going to obtain 2,144,66, which is cubic millimeters. You are given the radius there. Everything is given. 7.22. If the radius of the ball is doubled, write down the ratio of the new volume to the original volume. So this is it. When the radius is being doubled, what does it mean? 7.22. In terms of the radius that we had before, this one has been doubled. So meaning to say we are referring the new to the original. So if the original was taken in terms of the, I'm thinking of this distance is the radius. If the original is 1, then you double it. To double means times 2. You multiply it by 2. You have the new one. This here represents the ratio of what? This is ratio of sides, which is the ratio of the radius. We're considering the radii. These are sides. The question is not asking you about that. It is asking you about the volume, the ratio of the new volume. So you can take this as a ratio to say K is your ratio, which is the one that you have on the new and your original. But when they talk about the volume, the K, which represents the ratio, must be raised to the exponent of 3. So you must raise whatever that you have there to the exponent of 3 to have the ratio of what? Of volumes. So for ratio of volumes now, as you consider the volumes, the new one, we raise this to the exponent of 3. The original, we also raise to the exponent of 3. Now we talk of volume. If it was area, K squared, that is how you have it. You raise to the exponent of 2. To the exponent of 3 is what? Volume. So 2 to the power of 3, that was going to be 8. 1 to the power of 3, that's 1. So this is the ratio of volumes now. The new one to the what? To the original one. Just like that. With question 7.23, they are saying, you would like this ball to be silver plated to a thickness of 1 millimeter. They gave you a thickness. What is the volume of silver required? So in order for you to have the volume of the silver, you have to remove the volume when it is involved, because there's a thickness there of 1 millimeter. Remember, originally your radius was 8. Now there's a thickness which is added of 1 millimeter. Meaning, say our radius is going to be what? 8 plus 1. Meaning, say we've got 9 millimeters. It has been affected. So for you to remain with the silver only, the volume of the silver only, you're supposed to remove that what you consider as what? The ball on its own from when the silver coating or plating was involved. So it's simply the difference in terms of the volumes. So for us to have the volume, this is the volume of what? Of silver required. When the radius is now at 9, with the thickness that we are given, what is your volume? The volume is not going to change. It's still a sphere. We just coated with this part of silver. But the ball is still a sphere. Does not change. So we are going to calculate its volume using the new radius because of what? The thickness that you are given. This is to the exponent of 3. So this is like the new volume. When the silver plating is involved and the ball is there. But remember, originally we have the volume of what? Of the ball on its own when it was not coated with any silver, when it was not plated with any silver. Its original volume is there, 144.66. So you must remove it to the volume when the silver and the ball combined, they have this volume combined together. So that was going to give us 3,053.63. We subtract the one that we had originally when the ball was not coated with anything. That was going to give us 908.97. The difference there in what? In cubic meters. So we have the volume of the silver coating according to our presentation of our question. So we just need to revise, as we can see, more questions, because questions can be like this one where you need to figure out how the formulas are given. From the first presentation of our question, we saw that it was actually a question where you need your concentration to be available to the maximum so that you can be able to answer that type of a question like this one that we're having. So let's revise as many questions as we can. Where there are questions, comment section is there so that we can discuss about those questions and how to work out similar or any other questions of this nature. Till we meet again.